Alright guys, welcome back. This is our second day of e-learning. Hopefully that first lesson went well. If not, I will be answering your questions that you marked on the Google form. I'll be sending out a video later today that answers any of the problems that you had questions on from that homework assignment, so please make sure you have filled that out before you start this video. So today we're looking at the area of a regular polygon. So remember, a polygon just means something with multiple sides. This actually would find anything that has any number of sides as long as it's regular. Please make sure you remember the word regular means that all the sides have to be equal and all the angles have to be equal. So before we can look at the formula, we have a couple things we need to talk about. We need to look at the difference between what it means to be the radius of the polygon and what it means to be the apothem. So the radius of the polygon is a segment that goes from the center to the vertex. So we call this guy over here, we call him the radius. The important one today, though, is the apothem. The apothem, if you look at the definition, says that it has to go from the center and it has to be perpendicular to the side. So that should look like this, and he's the one that's going to be important for our area formula. So here is the area formula on this box. The A in the area formula, the little a, stands for apothem. So there are two things you're going to need for every problem that we do today. Is you need to know the length of the apothem, which they're going to give you. You just have to be able to locate it in the picture or in the problem. And then the other part, the capital P, I need you to think about for a second what that could mean based on what we've talked about in geometry. The capital P would refer to the perimeter. So remember, perimeter means you're going to have to add up all the sides. That's all the outsides. That's what perimeter is. Okay? So let's take a look at some examples now. There are two different ways that they could present these problems to you. It could be in words, or it could be in a picture. So we're going to practice both ways. I'm going to write the formula over here. It's 1/2 little a times p. So I always write down that I need to know those two things first. I need to know what little a is, and I need to know what p is. In the word problems, when they're writing it out, they tell you little a is 29.1, so we're good there. We also need to find p, which they do not tell you, but they give you enough information to figure it out. This is telling you right now what one side equals. One side of the polygon is 28 feet, and they told you that it is a 7-sided shape. So all you have to do to find the perimeter is take the side, which was 28, and multiply by how many sides we know there are, which is 7. And then we get an answer of 196. So then to finish the problem, we still have to use that special area formula because it's a regular polygon. We have to do 1/2 a times p. So that is going to turn into 1/2 of 29.1 times that 196. And I just multiply the two numbers on my calculator, 29.1 times 196. And then for the 1/2, I divide it by 2. So you end up with the area for this problem being 2,851, times 0.8 feet squared. Okay, so let's try number 2 a little bit here. So number 2, again, I need to know A and I need to know P. A is 60.4. P is going to be the side length, which I know is 50, times how many sides an octagon has. So there is a little bit of remembering you have to do here. An octagon has 8 sides, so it's 50 times 8, which tells me the perimeter is 400. And then to get the area, it's 1/2 of 60.4 times 400. And again, I'm letting the calculator do all the hard work. I'm doing 60.4 times 400 on the calculator, then divided by 2 because of the 1/2. Some of these answers will be a little bit bigger because we're talking about bigger shapes. So it's 12,080 inches squared. The bigger those side lengths get, the bigger the area is going to get. Alright, then looking at number 3, it's the same thing just in picture form. So I know the apothem in the picture is the one that makes the right angle. So when I'm looking for the apothem, that guy right there is the apothem. So that's A. So I know A is equal to 6. And then I need to calculate out the perimeter. I know one side is 3.9, but then I need to count how many sides there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides for this shape. So it's 3.9 times 10, which is 39. And then I'm just plugging that into the area formula. That's 1/2 of 6 times 39. And I multiply that out on my calculator. 6 times 39 divided by 2 is 117 inches squared. Number 4 has some bigger numbers, so this is just going to come out to be a bigger answer. The apothem is that line that's going perpendicular to the side. I know my apothem is 24.3, and then to find the perimeter, I have to take the side length, which is 50, and multiply it by how many sides we have right now. There are 1, 2, 3, 4, 5 sides. So it's 50 times 5, which is 250. And then I'm just plugging into the formula 1/2 the apothem, 24.3 times the perimeter, which we calculated out to be 250. And I'm going to type that in my calculator. 24.3 times 250 divided by 2, 3,037.5 centimeters squared. Okay. Alright, on this page we have a new formula. This one only applies to triangles, so I need you to pay attention. If it's a triangle, you can use this formula, and this is shorter than the other formula. But you have to understand what you get to plug in. In order to use this formula, you have to know the side. So S stands for the length of the side. If you don't know the length of the side, you'll need to find it first, which we're going to see in an example problem today. But that has to be what you're plugging in for S. So S is always the length of the side. Doesn't matter which side because they're all equal. So in number 1, it says find the area of an equilateral triangle with a side length of 6. So that is telling me that S equals 6. So I'm just going to plug that straight into the formula. 6 squared radical 3 over 4. Order of operations says I need to do the exponent first, so that's 36 radical 3 over 4. And then I would like to see you reduce these numbers here. So I can reduce those 36 when you can. If you can't reduce them, you just leave it as a fraction. But if you can reduce them, we reduce, and that's going to be 9 radical 3 centimeters squared. Since we're still finding area, we should be squaring the units. Alright, the second one's a little bit more complicated. It says find the area of an equilateral triangle with a perimeter of 48 centimeters. So this tells me what the perimeter equals, but I can't plug the perimeter into the formula. The only thing I can plug into the formula is the side length. So you have to think about what math you need to do to figure out what the side length would be. So they're telling me if I look at this triangle, that the perimeter, to go all the way around this shape, the perimeter is 48. All you got to remember is that it has 3 equal sides. So to figure out the side length, I have to take the 48 and divide it by 3. Which means for this particular problem, the side length is 16. So that's what I'm allowed to plug into the formula. I'm going to do 16 squared radical 3 over 4. 16 squared is 256 radical 3 over 4. And again, your last step is to see if you can divide these outside numbers. We're going to have to keep the radical 3 in the answer. So these will always have a radical 3, but see if you can divide the outside numbers, which you can here. You get 64 radical 3. And then this was in centimeters, so centimeters squared is our unit. The last one, number 3, what I need you to recognize looking at that is that even though it's a picture, that this is a equilateral triangle and they're giving you the side length, so you can use the same formula. The side length right now is 8, so I can put in 8 squared radical 3 over 4. I get 64 radical 3 over 4. And then I'm trying to divide these outside numbers to simplify it down. And you get 16 radical 3 inches squared. So all of those should have radical 3's in their answer. You're just going to leave those alone. but see if you can reduce them. If you can't reduce the outside numbers like has happened, you'll just leave it as a fraction. So there are a couple problems on Class Kick for you to try. I would like you to try those problems. It does give you the note when you get to these last problems, like if I wanted to enter 16 radical 3 in the Class Kick to type it in, I want you to do 16 V3. So just pay attention to that note when you get to that page. That will allow it to check it correctly. And then there is a homework assignment posted that I would like you to do. It's again due by the beginning of class on Wednesday. So just make sure that you are keeping up and getting those turned in, because those are for points, just like we would do if I walked around the room and checked it, but this time I'm having you turn it in digitally so I can check it. There will be an answer folder that opens up with those answers, so make sure you check those at the beginning of class and fill out the Google form, and I will again be making a video to show you which ones you guys need the most help with. Keep chugging along, keep up with the work, and if you have any questions, please email me, message me on Schoology, whatever you need to do to get a hold of me so that I can make sure that you're understanding these lessons even though we're not together.